Now we are going to discuss about some different types of matrices. First one is we are going to discuss about row matrix. Row matrix. What it means? Row matrix means if a matrix, when we write a matrix, if it has only a single row, that is called as a row matrix. For an example, here I write 1, 2, 4. So how many rows in this matrix? The row number is just 1. No? So this is a row matrix, not only this one. We can write -7. No need to worry about the columns. The row should be exactly 1. Okay, one more example. Here I have 0, 7, 5, 3. Okay, how many rows in this matrix? Only a single row. If a matrix contains only a single row, that is called as a row matrix. Likewise, we have another type, that is column matrix. Now you can easily understand what is meant by column matrix also. In the column matrix, a matrix should contain only a single column. For an example, I'll use 5 and 2. We are just considering about the vertical alignment. That means the column. How many columns here? Only a single column. So this is a column matrix. 0. How many columns here? Only a single column. This is also a column matrix. 5, 4, -5, 0. How many columns here? Only a single column. So this is also a column matrix. Next type is square matrix. Square matrix means if the number of column and number of row both are equal, that is called as a square matrix. We are not writing any notes. By looking at the example even you could understand. So here I'll use 1, 5, -3, 7. Okay. So how many rows? 1, 2. There are 2 rows. How many columns? 1, 2. There are 2 columns. So this is a square matrix. Okay, here we have only one row and a single column. This is also a square matrix. One more example. 5, -1, 0, 7, 6, 5, 2, 3, 8, -8. In this case, how many rows are there? Let's count. 1. So this is a row. This is another row. And this is another row. So there are 3 rows. There are 3 rows. How many columns? 1, 2, 3. The horizontal alignment is the row. Vertical alignment is our column. There are 3 columns. Here also the row number and column number both are same. So this is classified as square matrix. And one important thing, this one, look at this. The row number is 1. So it can be a row matrix. The column number is 1. It can be a column matrix. Since the row number and column number both are same, it can be a square matrix as well. This matrix is obeying all 3 conditions which we have studied up to now. It can be a row matrix, it can be a column matrix, it can be a square matrix as well. Next one is symmetrical matrix. So symmetric matrix means here we are just considering about square matrices. If that is a square matrix only, it could be a symmetrical matrix. For an example, here I have 2 and 2, here 5, no. So 2 and 3, here 5 and 5. So this is called as main diagonal. Okay, in this in this square matrix, since the row number and column number both are same, it can be a square matrix. In the square matrix, if this is called as main diagonal, right hand side and left hand side value with respect to the main diagonal, if those are same, this is called as symmetric matrix. It doesn't matter with the, this is called as primary diagonal. Doesn't matter with the primary diagonal. It can be same values, it might change with other values, doesn't matter. But with respect to the primary diagonal, right hand side value and left hand side value, if both are identical, that's called as symmetric matrix. So through this axis, this side and this side showing symmetry. That is meant by symmetrical matrix. Mostly we are using 2 into 2 and 3 into 3 matrices. I will show one more example. Here I have 7, 5, 2, 0, 3, 1, and here I have 0, 3, 1. Okay. So when you look at this, except this primary diagonal, all the other values which are situated in left hand side and right hand side values which are identical. Okay, here you can see kind of mirror image. You can clearly see kind of mirror image. This is also a symmetric matrix. One important condition, only square matrices are applied to the condition of symmetric matrices. Okay. Except the primary diagonal, the right hand side value should be exactly equal to the left hand side value. If so, that can be a symmetrical matrix. Next classification would be identity matrices. Okay. Identity matrices is kind of unique type of matrices. You should use this one in most of your calculational purposes. Okay, identity matrix means this is a type of square matrix, but here the condition is the main diagonal should have the values as 1 and other value should be 0. This is an identity matrix. Look at this. The main diagonal should consist of the values are 1. Okay. Main diagonal should consist of the values of 1 and other values are 0. I'll use another square matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. Look at this. Except the main diagonal. This is our main diagonal. No, except this main diagonal, all the other values are 0. Okay, these kind of unique type of square matrices are called as identity matrix. We are using capital I letter to denote the identity matrix. What is the order of this one? There are 2 rows and 2 columns. Here there are 3 rows and 3 columns. Only the identity matrices are applicable to the square matrix. If the main diagonal consists of one value and other values are 0, those kind of unique type of square matrix would be our identity matrix. There are some difference between symmetrical matrix and this one. I will show you. Symmetrical matrix means it doesn't matter with the primary diagonal. Other values should be same. But in this case, restriction. Primary diagonal should have 1. Other values should be 0.